Hi, everybody, and welcome to today's CFM Talks webinar, Cloud Financial Management Talks. I'm Lisa Harnett, the host of our CFM Talks series, where we talk about managing, optimizing your spend on AWS. I'm happy and so excited actually to have Carlos Galen here from our Cloud Economics team to talk about 9 ways to reduce your AWS bill. We've been working on this for the last month, and we're really excited to be able to present it to you. Each one of the talks in this series is designed around answering questions that we hear from customers like you. We've heard customers like you around the globe. Many are facing unexpected spikes in costs or situations that are far from clear. They don't know what's going on. And the cloud allows you to trade those fixed expenses, such as your data center and physical servers, for variable expenses, and only pay for IT as you continue to use it. And that means that you change and ask yourself all the time, why is my cloud bill different this month? Are we spending efficiently? How would I even know? And what can I do today to lower my bill? I've also heard about these commitment-based discounts. Are they worth it? How do they actually work? So we designed this session around answering those kinds of questions. Whether you're seeing usage increase because your customers are relying more than ever on your services, or you just want to optimize the spending that and provide the best price per performance, there are things that you can and should do to optimize your cloud costs. And over the rest of this session, Carlos will highlight 9 simple cost optimization initiatives every customer should consider, depending on their circumstances, some of which you can implement right after this webinar. And now I will turn it over to Carlos, who will go over the agenda. Thanks.
Thank you, Lisa, and welcome everyone. I think first we will have a quick look at what makes up cost in your AWS bill, and then we'll dive deep into the 9 ways, as Lisa was explaining before going over some final thoughts and some Q&A at the end. First of all, it is important to understand that to tackle cost, we need to know where cost comes from. Okay. So essentially, it comes from 2 sources, usage and rate, as in usage times a rate equals cost. And to give you a couple of examples, in the case of an Amazon EC2 compute resource, for example, you use it for 720 hours this month. That is 30 days times 24 hours, meaning all the time on during the month. And you pay a rate of 0.0336 per hour, which gives you ultimately a cost of $24.19 this month for that particular item. And for every resource that you use, you have a similar structure. In the case of an Amazon S3 storage resource, for example, if you use it for, you use 550 gigabytes of stored data that month, you pay a rate of 0.023 per gigabyte per month, and that gives you a total of $12.65. Therefore, cost optimization initiatives is very important, ultimately operates across 2 levers, right? So on one hand, you can optimize usage. In other words, just use only what you need. And this is all about reducing waste and also improving your carbon footprint as you do so, right? On the other hand, you can optimize rate. In other words, pay less for what you use, no? And this is all about finding the most cost-efficient way to operate your workloads. So the following on screen is a compilation of 9 ways to reduce your AWS bill. The first 4 are going to focus on helping you to use only what you need, whereas the last 5 are going to help you to focus on paying less for what you use. So let's begin. Number 1. Stop paying for underutilized Amazon EC2 and Amazon RDS instances. And let's run a few scenarios here. So scenario 1, if you're running EC2 workloads that are compute intensive, but not particularly memory intensive, and these EC2 instances utilize less than 40% of the CPU capacity, then you are paying for over-provision instances. The right sizing recommendations feature in AWS Cost Explorer helps you to identify cost-saving opportunities by either downsizing or even terminating altogether these idle EC2 instances. This feature is based on millions of hours of internal Amazon machine learning frameworks, as well as similar workloads powering the the actual Amazon retail side of the business. It analyzes the last 14 days of historical usage of your Amazon EC2 resources and shows opportunities to lower your spending by helping you to use only what you need. Our recommendation is to review this feature to determine which EC2 instances you can right-size or terminate. While it takes minutes to hours to review the recommendations, it might take days to perform the actual resource operations, depending on whether these EC2 instances are running in production or non-production environments. The savings potential can vary from hundreds to thousands and can be realized as soon as these EC2 instances are right-sized or terminated. And there's no commitment required. So, how to get started? First, enable the right sizing recommendations using your AWS Cost Explorer settings options. It might take up to 30 hours to receive your first set of recommendations. Then you review the recommendations and determine your priorities based on, for example, a balanced view of how critical the environment is versus the potential savings you can get from each of these. And finally, once you have determined this, then you may proceed to right size or terminate them accordingly. Next scenario. If you have workloads running in non-production, let's call it non-critical environments such as development, staging, testing, QA, and it is not part of your existing operational processes to shut down these resources during evenings, weekends, or holidays, then you might be paying for every EC2 second and RDS hour of idle time. AWS has made it easier to define a schedule across member accounts by providing a pre-built, easy to deploy, CloudFormation-based solution called the AWS Instance Scheduler. It enables you to easily configure custom start and stop schedules for both EC2 and RDS instances, again, helping you to use only what you need. The instance scheduling allows you to stop and restart EC2 and RDS instances. When these instances are stopped, you no longer incur hourly charges. In this graph that you see on screen, for example, you can see how elasticity is being leveraged over the weekend to reduce the EC2 costs. Our recommendation is to start using the AWS Instance Scheduler to reduce your on-demand EC2 and RDS cost as soon as you identify all the, let's call it, eligible resources. It takes minutes to hours to implement, depending on the environment, the size, the complexity. Customers who use the solution to shut down instances from, let's say, Friday 6 p.m. to Monday 6 a.m. can save up to 35% compared to running those instances all week long. Actually, if the nature of your business allows, you could even explore scheduling instances to also be off during evenings on weekdays, where you could double your savings, this time up to 70% compared to on-demand pricing all week long. These savings can be realized in minutes, and there's no commitment required either. To get started, so first install the AWS Instance Scheduler by either downloading the CloudFormation template or by launching the solution directly into your AWS console. Then you create a schedule based on your business requirements. And finally, you apply a custom tag to all these applicable non-production EC2 and RDS instances, so we know who we need to schedule, pretty much. Number 2, stop paying for underutilized network and storage resources. So a scenario is you have created network and or storage resources. And to give you a few examples, we can talk about Route 53 records, or elastic load balancers, or elastic IP addresses, or EDS volumes that are not being fully used, and you're still paying for those resources. So with AWS Trusted Advisor, you can identify these resources that need to be cleaned up, helping you to use only what you need. AWS Trusted Advisor is a service available to all customers and provides additional functionality to customers who subscribe to either business or enterprise support plans. It inspects your AWS environment and makes recommendations amongst other for cost optimization. You can identify underutilized Route 53 records, idle elastic load balancers, unassociated elastic IP addresses, and unattached or idle EBS volumes that you may be able to eliminate. It's important to note that most of the checks run against a 7 to 14 day historical usage. So for customers using business or enterprise support, our recommendation is to review underutilized resources in your AWS Trusted Advisor console and either delete or stop these resources. While it takes minutes to run the checks, it might take hours to days to clean up all the identified resources. And the savings potential can vary from hundreds to thousands, which can be realized as soon as these resources are cleaned up, pretty much. To get started, so log on to the AWS Trusted Advisor section from your AWS console and either run or refresh the cost optimization checks, okay, very important. Then review the set of recommendations and estimated monthly savings opportunities for your account. And finally, you can prioritize the resource cleanup based on potential, for example, the greatest savings or the environment again. Number 3, fine-tune your Amazon Redshift clusters. So the scenario is, if you have Redshift clusters and also have resource constraints around resizing clusters in production or around shutting down clusters in non-production environments during evenings, weekends, and holidays, you might be paying for over-provision or idle Redshift clusters. And AWS has made it easy to resize, pause, and resume Redshift clusters. As your data warehousing needs change, you can resize your cluster to make the best use of the computing and storage options that Amazon Redshift provides. You can use Elastic Resize to add or remove nodes for multi-node clusters. And if you have a cluster that only needs to be available at specific times, you can pause the cluster and resume it later. During these, let's call it periods of on-demand billing is suspended, and the clusters, during this time, the cluster storage incurs charges, again, only, right? Again, helping you to use only what you need. Our recommendation here is to either use Elastic Resize to modify the size of the clusters, or you pause and resume them to reduce the on-demand Redshift costs. It takes minutes to hours to implement depending on the environment size and complexity. Customers who use Elastic Resize can save hundreds to thousands, while customers who pause clusters from Friday 6 p.m. to Monday 6 a.m. again, similar to the previous example, can save up to 35% compared to running these clusters all weekend. These savings can be realized in minutes, and again, there's no commitment required. So this is the combination of the same right sizing and scheduling motions we saw on the previous initiatives. So you can see a pattern of what using only what you need means on AWS. To get started, you can create Elastic Resize and or pause and resume schedules on a per Redshift cluster basis using the AWS console. For more information, you can visit the links at the bottom of the slide. Number 4, fine-tune your serverless resources, in particular, AWS Lambda and Amazon DynamoDB. If you're using serverless compute resources, right, like AWS Lambda, and you haven't performed any fine-tuning to your functions, you might be paying unnecessarily for all your Lambda executions. Fine-tuning Lambda functions by choosing the right memory allocation is an optimization process that balances speed and cost. While you can manually run tests and functions by configuring different memory allocations and measuring the execution cost, The AWS Lambda Power Tuning tool allows you to automate this process as well. To give you a little bit more explanation, AWS Lambda charges for the total amount of gigabyte seconds consumed by a function, okay, which is the product of the memory configured in gigabytes and the execution duration in seconds. And therefore, increasing the memory has an impact on the overall cost, assuming that the total duration stays constant. However, in many cases, increasing the memory available achieves both a decrease in the execution duration, as well as achieving the lowest cost for your Lambda executions. So in this example that you see on screen, you can see how this particular function has the lowest cost at both 1024 megabytes of memory and 1536 megabytes of memory, with an increased execution performance on the latter, right? So that you want to find that sweet spot. A recommendation is to perform fine-tuning of your Lambda functions, either manually or by using the AWS Lambda Power Tuning. Your savings potential will depend on the average number of executions your functions have in a month. And to quantify your potential savings, obviously you multiply this number by the cost differential that you have achieved through the fine-tuning exercise, which will depend on the type of workload. And you will start realizing savings as soon as your functions are fine-tuned in a few minutes. To get started, there's 3 steps to follow. Right? First, download the tool. Second, you can read the instructions for how to run based on a cost optimization strategy. It's very important. And third, just perform the fine-tuning of your Lambda functions, of the chosen ones. That's the first scenario. Let's go to second scenario. If your application traffic is difficult to predict and control, or your average table utilization for your DynamoDB tables is well below the peak, and you're using provision capacity for your DynamoDB tables, you might be paying unnecessarily for provision capacity. So Amazon DynamoDB OnDemand Capacity mode is a flexible billing option for DynamoDB, which is capable of serving thousands of requests per second without any capacity planning, right? And you only pay per request, which is the reads and writes your application performs on your tables. You do not need to specify your application expected throughput, as DynamoDB instantly accommodates your workloads as they ramp up or down, helping you to use only what you need. Amazon DynamoDB Standard Infrequent Access table class helps you also to reduce your DynamoDB cost by up to 60% for tables that store data that is infrequently accessed. And this is ideal for things like application logs, old social media posts, e-commerce order history, and even past gaming achievements. A recommendation here is to configure your DynamoDB tables with on-demand capacity for tables as you continue to grow your DynamoDB usage. And this takes minutes to implement. Your savings potential will depend on the number of reads and writes your application performs on your table, as well as how dominant the storage component is to the overall cost of your tables as well. We recommend switching to on-demand capacity mode and/or the infrequent access option for a short period of time, and then compare your cost to those of your as-is configuration, right? Just to make the comparison. You will start realizing savings as soon as your table is configured with on-demand capacity and/or standard infrequent access table class. So there's 2 ways to save with this scenario. You can toggle between provision and on-demand capacity modes every 24 hours. And you can switch between the DynamoDB standard and the DynamoDB standard infrequent access table classes with no impact on table performance, durability, or availability, and without changing your application code. It's that simple. To get started, you can simply configure on-demand capacity and/or standard infrequent access table class for the existing DynamoDB tables or for new tables as well. Number 5, this is enable Amazon S3 intelligent tiering. So the scenario is, if you're using S3 standard storage class, either for general purpose, let's say hosting a data lake, for example, you might be paying unnecessarily for S3 storage classes you don't need, okay? If you don't have time to analyze your usage and implement lifecycle policies, you still have the option to use S3 intelligent tiering, which is a storage class designed to optimize costs by automatically moving data between 3 different access tiers based on changing access patterns, right? So it does this for you. And you start by the frequent access tier, then moving to infrequent access tier after, let's say, 30 consecutive days without access, and then moving into the archive instance access tier after 90 consecutive days without access. This tool can be used as some form of insurance policy, right? For a small monthly object monitoring and automation fee, objects will be shifted accordingly between the 3 tiers without any management overhead, any lifecycle charges, any retrieval fees, nor any minimum storage duration, helping you to pay less for what you use. Our recommendation is to enable S3 intelligent tiering as you continue to grow your S3 usage, and this takes minutes to implement. Once you enable it, it takes 30 days to realize savings for objects transitioning to infrequent access tier. Getting at this point, you can get a 40% discount on these objects. And then it takes 90 days. Sorry. Sorry about that. Sorry, and then it takes 90 days, which is the previous 30 plus 60 more days, to further increase savings for objects transitioning to the instance, to the archive instance access tier. And at this point, you're getting 68% discount. So we have seen overall customers saving overall between 20 to 40% on S3 storage costs by using this tier. You save the most if you write directly to the S3 intelligent tierage storage class instead of writing to the S3 standard and then moving objects by a lifecycle policy. Also, we recommend you to start using S3 intelligent tiering for targeting larger size objects, right? Anything above 1 megabyte, for example, as the monitoring and automation considers number of objects managed, but not their size, right? And this way you can maximize your return on investment. Objects that are smaller than 128 kilobytes will not be managed across tiers, but at the same time, you will not be paying a fee for this either. And again, there's no commitment required to use S3 intelligent tiering. There are multiple ways to get started actually, but here are some examples on how to do it. So for new objects with unknown access patterns, which is what we're recommending to use this service for, you can load them directly into the S3 intelligent tiering storage class, and you just let AWS automatically optimize your S3 costs. For existing objects, right, once you enable this, you can create lifecycle rules that actually transition this to the intelligent tiering storage class, and once they're there, they operate as everyone else, right? So it's just try to find that balance. Okay, so number 6, enable EC2 spot instances. The scenario is if you're running what you call stateless, fault-tolerant, and loosely coupled workloads, such as big data, containers, CI/CD pipelines, web servers, high-performance computing, or even development staging, and you're currently paying the default on-demand pricing for these particular workloads, then Amazon EC2 Spot is a great candidate to reduce costs. So Amazon EC2 Spot instances, they let you take advantage of unused EC2 capacity in the AWS cloud. And you have the option to either hibernate, stop, or even terminate your Spot instances when EC2 reclaims the capacity back, with a 2-minute notice. So you have 2 minutes to fix to get prepared for that. Again, helping you to pay less for what you use. Whether now or as you build the future applications, you should be looking to use Spot for all applicable workloads. Our recommendation is to use Spot instances for workloads, again, that are stateless, fault tolerant, and loosely coupled. And also start thinking about a Spot first approach whenever you're developing any new net workloads, right? Just always keep them in mind as you start architecting the future workloads, so you have this option, right? The implementation can take hours or days for workloads that are already in the ideal state, or it can take weeks depending on the environment sort of complexity, right? Spot instances are available up to a 90% discount compared to on-demand prices, say 90%, 90. And the time to realize the savings depends on when it's implemented. Spot instance prices are set by Amazon EC2, and they adjust gradually based on long-term trends in supply and demand for the Spot instance capacity. If you implement Spot now, you can start realizing the savings now, and again, no commitment is required. Here, just some self-service practical references that will help you accelerate your adoption of Spot today. Number 7, modernize your resources. In particular, we will be talking about Amazon EC2, Amazon RDS, and Amazon EBS. So the scenario is, if you're running workloads on previous generation EC2 or RDS instances, or if you have EBS volumes on previous generations, you might be already overpaying for your resources. So using the latest generation of EC2 and RDS instances across instance families has multiple advantages, such as better hardware performance, better virtualization technology, and lower costs. Likewise, using the latest generation of EBS volumes can provision, so with this, you can provision IOPS and throughput independently, allowing you to provision smaller volumes while still maintaining high performance, and of course, therefore, lowering costs. In both cases, again, helping you to pay less for what you use. So even though we will continue to support previous generation instances after these new types launch, we still encourage you to explore using the latest generation of instances to get a better performance and lower costs. For Amazon EC2 instances, for example, you can get better on-demand rates and performance as you move your instances from, for example, class C3 to C4 and to C5, as you can see on screen. Likewise, for EBS volumes, for example, you can get a better gigabyte per month rate as you move your volumes from GP2 to GP3. Our recommendation here is to first explore, very important, the latest generation of all instance types that you have in your environments. Then understand also the technical requirements involved. And there's a ton of online resources that you can see in the next slide as well. Once you have that, you can finally prioritize these upgrades based on savings potential, on what sort of environment you are, if it's development or production, etc. We would also recommend to begin with those instances that are running on demand, right? Not covered by a savings plan or a reserved instance, as we will speak in a little bit. The implementation can take hours or days for workloads that are already in the ideal state, or it can take weeks depending, again, on the environment complexity. Then, depending on both the instance family, for example, in the case of EC2, you have the general purpose instance families like M or T, which is different from the compute optimized instance families like C. So depending on this instance family, and also on the generation jump, right? It's very different to perform it's called a jump or migration. between a C3 to C4. This is very different than to do it from C3 to C6G, for example, right? Very different. So different instance families and different generation jump. The EC2 and RDS instance upgrades can provide anywhere between 5 and even beyond 40% discount compared to on-demand prices. So obviously, the larger the jump, the more discount you can achieve, as the latest generation ones have the higher discount. Likewise, upgrading your EBS volumes from GP2 to GP3 can yield up to 20% cost savings. And these upgrades can be completed with 0 downtime, while still retaining the full gigabyte size for those volumes. It is just that easy to do. The time to realize the savings will depend on when it's implemented, and the upgrading requires no commitment either. Here are again some self-service practical references that will help you accelerate your modernization opportunities today, to try to understand the requirements to move from one generation to the other one, including exploring the use of AWS Graviton, right, which is a 64-bit ARM processor designed by AWS to deliver the best price performance for your cloud workloads within their instance families, either running on Amazon EC2, RDS, and even Lambda. Number 8, use compute savings plan. If your workloads are indexed on compute resources that are always on, or your usage is pretty much consistent, and you're currently paying the default on-demand pricing, then AWS compute savings plans can help you reduce the cost of those compute resources. AWS compute savings plans allow customers to commit to a consistent amount of the usage in the form of an hourly spend in exchange for a lower price for that usage, right? Helping you, again, to pay less for what you use. Compute savings plans provide the most flexibility and help reduce usage costs with discounts up to 66%. On one hand, these plans automatically apply to EC2 instance usage regardless of instance family, size, availability zone, region, operating system, or even tenancy. And on the other hand, compute savings plans also allow you to shift workloads seamlessly between EC2, Fargate, and Lambda at any time, while still continuing to receive discounts. Obviously, the size of the discount is different whether you are on EC2, Fargate, or Lambda, but it's all counted, and it gives you that flexibility. Our recommendation is to start with a, let's say, 1 year no upfront compute savings plan, and it takes hours to implement. Compared to on-demand prices, it provides up to 54% discount, and the savings can be realized within hours of purchase. This definitely requires a 1 year commitment, but the break-even point is typically between 7 to 9 months. So, how to get started? In your AWS Cost Explorer console, you can review your savings plans recommendations, customize those recommendations based on your needs, such as the term length and payment option, right? So you can decide whether it's 1 year or 3 year commitment, or whether that is a no upfront, partial upfront, or all upfront. And lastly, you can add your preferred savings plans amount to the cart and purchase. Right? This amount can be the fully recommended amount by Cost Explorer, which is a commitment value estimated to result in the largest possible savings for you. However, if you prefer a more cautious approach to start building gradually, that commitment strategy, or you are unused what your future growth entails, then you could manually look at your compute spend over, let's say, the past 30 or 60 days, and you commit only to the lowest common denominator, so that amount that you see every single day as usage, then you can commit to that. Number 9 is use reserved instances. So the scenario is, if you have workloads that are indexed on RDS, Redshift, Elastic Cache, and or OpenSearch resources that are always on, and you're currently paying the default on-demand pricing, AWS Reserved Instances can help you reduce the cost of those resources. A reserved instance is a pricing model that provides you with a significant discount when you commit to usage of specific RDS, Redshift, Elastic Cache, and OpenSearch resources, helping you as well to pay less for what you use. Our recommendation here is also to start with a 1-year no upfront reserved instances, and it takes hours to implement. Compared to the on-demand prices, they provide up to 42% discount, and the savings are realized within hours of purchase as well. Each reserved instance requires a 1-year commitment, but the break-even point again is typically between 7 to 9 months. So here's how to get started. Very similar to Compute Savings Plan. In your AWS Cost Explorer console, you can review your reserved instance recommendations, customize those recommendations, again, based on your needs, such as term length and payment option. And lastly, you can purchase your preferred reserved instance from the survey-specific page in the AWS console. Just like with savings plans, the number of instances to reserve can be the fully recommended amount by Cost Explorer, or you might prefer, again, a more cautious approach to start building gradually that commitment strategy. Or again, if you're unused what the future growth entails, you can manually look, again, for example, let's say at your Amazon RDS hourly usage for the M5 instance family over the past 30 to 60 days. And again, you can commit only to that lowest common denominator that you see always on. That's the most cautious approach again. And you can still pretty much, so the good thing about the cautious approach, both for compute savings plans and for reserved instances, is that you can always increase the level of commitment as you can have multiple savings plans or reserved instances in parallel as well. So here's a mapping that shows how you can balance the implementation of these 9 types of optimization based on commitment levels, implementation time, and knowledge level. Our recommendation is to, very cautiously, to start with the ones you can implement the fastest in order to reduce your AWS bill. In particular, those that you can see on the lower half of the matrix, right? Just those 6 at the bottom. And then some final thoughts. Although we have shared 9 pragmatic ways to reduce costs today, there are a number of self-service options for you to use in your cost optimization journey. Pretty much, to understand your cost, you can use AWS Cost Explorer. To control your cost, you can use AWS Budgets. And to optimize your cost, you can use the AWS recommendations, whether that is from Cost Explorer, Trusted Advisor. We know that every organization is different, and you may not have seen your scenario in this presentation. And if you didn't, there are other sort of AWS resources available. So thank you very much for your time, and feel free to make any questions because we're here to help.
Thank you, Carlos. That was great. We've got a pile of questions in here that we've been answering in the background. I'm going to ask some of them to you now. One of the ones that I want to cover quickly is that we have a couple questions about the handout for this. You'll get an email from us with the survey, but also we'll have the link to the handout, as well as this will be recorded, and the recording will actually be placed on the same page that you registered. So that recording will be in that same location. So we had a lot of questions around that. But for Carlos specifically, we had questions around costs. We talked about a lot of different tools in here. Which ones of those are free, and which ones of those have an incremental cost?
That's a good question.
Do you want me to go back to the slide that has all of the different?
Sure.
To go back
yeah,
to
that would
the
help
slide that has the
that.
list of all the things. I'll grab that.
Yeah. I would say right off the bat, AWS Cost Explorer, which is a tool that we have discussed throughout the presentation, is pretty much free to use unless you are leveraging things like hourly evaluation of your cost, right? Which is that sort of granularity. But if you're just looking at your cost on a daily basis, monthly basis, you can use all of these functionalities, the recommendations. You can even forecast your cost with AWS Cost Explorer at no additional cost. So that is one important one to have a look at. And I think the other one is AWS Budgets. You can obviously configure your things on to control your cost, but anything that you trigger from AWS Budgets obviously is going to trigger cost, depending on what you exactly do, especially if you use things like AWS Budgets actions that trigger specific actions. Those actions may trigger additional cost, but just to keep in mind.
Okay, so from a recommendations perspective, Cost Explorer is free. Compute Optimizer is also free unless you've got extra metrics turned on. Is that right? And then like Trusted Advisor, certain levels are free, but other ones come with enterprise support, right? Those are the ones I was thinking about, right?
Yeah, Trusted Advisor, yeah, definitely. You have a free tier available for everyone. But then, especially the cost optimization one, definitely need to have business or enterprise support to have access to those.
Okay, and then we had a question on what's the difference between intelligent tier and the data lifecycle?
The difference.
Can you go back into more? Yeah. So why would you use one or the other? The differences there.
Yeah, so there are a couple of differences. I think the main ones is that lifecycle. If you use lifecycle, is because you want. So sorry, let's just start again. If you use the intelligent tiering one, what you want to do is just let AWS take care of the lifecycle sort of movement between the tiers based on the usage, and you just pay a monthly fee per object, right? So it's that sort of service. Whereas if you want to take things a bit more, you want to avoid the monthly fee and you have a bit more certainty around the specific lifecycle that you're expecting from your objects, then you can do it manually via a lifecycle configuration.
Yeah, if I may, I'd love to jump in on that topic. So Michael Biddle, I'm one of our principal architects here for cost optimization, work with Carlos. And, some of the great use cases I see are the differentiator for why intelligent tiering versus time-based lifecycles. Typically data lakes, like you have unknown usage patterns, you're pairing up machine learning workloads that run at different times of the day, different testing patterns depending on what product you're experimenting with. That's one that tends to lend itself better for intelligent tiering than maybe a time-based lifecycle. Typically, time-based lifecycle is really best leveraged when, like, let's say you have reports that are needed to be made for like record keeping and compliance, and those need to live a certain amount of hours in your environment or a certain amount of days, and you can leverage that pattern around it where you're confident. I personally look at intelligent tiering as one of our best insurance policies against behavior. Everyone has the best intentions when we launch workloads, but what we've found is that sometimes things need changing and iterating along the way that you couldn't project for up front. So intelligent tiering, my recommendation is if you have objects that are between about a megabyte or larger usually, like don't look at the smaller objects for intelligent tiering, but if it's at least a megabyte and it's going to live in your environment for anywhere between 3 to 6 months, and you can't say today how often those are accessed, that's probably a good candidate versus a time-based policy. And there's another tool that's available called S3 Storage Lens, which we recommend checking out. That will help you get the pattern of insight for how often those objects are actually accessed. So if you want to get some data at first to kind of see how often those are being used before you decide between the two, S3 Storage Lens, which is used by Pinterest. There's a great customer use case that they've published on that. That'll be the tool to use to see how often they're accessed.
Thank you, Biddle. All right. We have a question also on number 7 and number 8. Do you recommend, like, what order would you do that in? Would you start with compute savings plans and modernize, or would you modernize and then do compute saving plans, or should you do something different with that?
That is, yeah. You can take it, Michael. Yeah.
Yeah, so I'll just quickly jump on that. So there's 2 scenarios you need to look at. If your environment is one where you don't already have compute savings plans enabled, and this is kind of your first foray, there's definitely an option where you can do savings plans and right sizing in tandem. So what you want to do is kind of do a stair-step model, procure something like maybe 25% of your environment initially via savings plans while you right size in tandem. Effectively, it's very rare that you've over-provisioned your environment to where more than 75% of what you're using would be either shut down or downsized. That's something you, of course, will want to look at and ensure, but that's a good starting point where you can take a low-risk offering while hedging your bet and right-sizing over the next month or few weeks as you get that in right. I would recommend really just kind of taking that report from AWS Cost Explorer for right-sizing first, or Compute Optimizer, and see what the scope is of those opportunities. Some of the instances where you might have some more time in front of you where it takes to validate the references is like R5 machines or R6Gs, R4s, really intense memory bound workloads. That's something where you'll want to leverage and look at the CloudWatch agent being installed on those machines to make sure that you're getting the right memory insight. But typically, if you're starting with your Cs, your Compute Optimizer, your T worker nodes, those recommendations are pretty spot on without memory insights, and you can start leveraging the right sizing immediately. Most companies can take anywhere between if you're really nimble, 1 to 2 weeks to make right sizing changes, but if you're a larger scale enterprise and you have a lot of decoupled and interconnected services, it could take you a month or 2. So if you don't have anything, start now with 25%. If you already do have savings plans in your environment, let's say you're procured over 50 to 75% coverage, I would seriously then look at the right sizing opportunity first, and you don't want to be in a position where you over procure.
Thanks. So we had a question earlier about what should you do if you're in a managed provider situation where they don't have access to Cost Explorer. What are the options there? I don't think we covered that in one of the answers yet, have we? Did I cover that? If you don't have access, because you use Compute Optimizer in that situation, you should still have storage blends.
Yeah, we put an answer in the chat, but just that's say you're buying from, like you said, managed service provider, you're still going to have access from the command line to pull recommendations from Compute Optimizer, more often than not, unless that managed service provider has taking that permission away from you, which in my experience is not something that they generally want to do, because we want to help you make the right references to your environment. So look earlier in the answered questions, there was a link I put in there where you can use the command line to describe those recommendations if you are in fact not able to look at those recommendations from a payer view in your organization.
Okay. Another question. Trying to go through the questions here real quick. There was one about, is there any tools for automating or executing on the recommendations on a real-time basis? I'm going to assume the answer is not, because we still have to figure out your requirements, right? Did it work for your environment?
Yeah, I mean, it's something, well, tell you this, there are different partner providers out there who have software and, tooling where you can say yes, I agree to the recommendation. It'll automatically make changes for you. That's assuming that you're okay with everything that's coupled with that, such as the AMI, the security groups, and that you've tested it. We've more or less taken the stance that it's probably best to do that testing, and we don't want to simply make that assessment for you without some consideration from you on the other end of it. So best practice is to take the recommendations we come up with, run it by your development and engineering teams, and have them do a test right away, maybe a 3 or 7 day POC with that new instance type. Run it on spot instances, even better, to save some money while you're doing that, and make sure it's going to accommodate the workload.
We have a question about EC2 snapshot costs. Is there anything that you guys can provide around optimizing those costs? Like how do you figure out where your snapshot cost is coming from, or?
Yeah, EC2 EBS Data Lifecycle Manager, that is the official tool. You can like go and look up, that'll give you age on those snapshots. Trusted Advisor will also tell you if you have really old snapshots, for example, like maybe you have something that's stored from 3 or 4 years ago that just can be cleaned up or terminated. Typically, what we see is that snapshots should not make up anywhere near the majority of your EC2 other bill. If you look at like the most cost optimized customers in AWS. So as a first check, if you look at EC2 other section in Cost Explorer, and you have snapshots as making up anywhere near like 30, 40, 50% of your bill, there's probably something there to investigate. And so our recommendation is to look at the versioning. Like, are you keeping a lot of versions on these snapshots maybe you don't need? That's usually a tweak in policy that can be made from talking with your engineering teams and really fine tuning. Other piece would be just like I said, how long these are stored for. Really, that's usually one of the most common areas to clean up. And so like I said, EBS Data Lifecycle Manager is the tool to probably get that best insight. There's another question here on what is better, reserved instances or savings plans. Carlos, maybe that's something you want to just take a quick stab at there. I know it's a common question that we get.
Yeah, well, usually, so when we started with this sort of commitment-based sort of price reductions or discounts, we started with reserved instances. That's all we had. No, that was our concept before, about just thinking about boxes. And being able to just reserve the boxes as you saw fit. What we have now is a bit more of an advanced sort of if you want to call it concept, which is the compute savings plans. And anything that has to do with compute, pure compute, which is EC2, Fargate, or Lambda, our recommendation is to always think about compute savings plans, because it gives you that much more flexibility. You don't have to think about types of instances. You don't need to think about, it's just like put everything on the same bucket. You have a little bit of a less sort of more milder, slightly milder discount, but still, given all the flexibility that it gives you, is usually a recommendation. And then anything that has to do, again, with RDS, with Elasticache, with OpenSearch, usually that still uses the sort of the reserved instance, which is not a bad model, but it's definitely the one that you want to look at for these kind of services.
I think just my 2 quick cents on it. I tend to lean more towards compute savings plans, especially if you're in an environment that tends to innovate rapidly, take advantage of new technology, and modernize. In terms of like what's the difference or trade-off, I kind of saw a question in the chat that was what's cheaper, the savings plans or reserved instances. A savings plan, a compute savings plan, which is going to give you coverage against anything in Fargate, Lambda, or whatever EC2 instance you're running effectively. It doesn't matter if it's like an M5 or R5, for example, it'll still cover you across families. So that compute savings plan, that is pretty much the same discount that you see with a convertible reserved instance. A standard reserved instance is going to match and marry more closely to what you get with a instance plan within savings plans, discount-wise. And so, I tell you what, if you are someone who's going to say, I'm making a very strong FinOps push in my organization over the next year, I want to drive modernization from my M4s to like M6G Gravitons, that just making that one move on that M4 footprint is going to save you about maybe 20 to 30% going from M4 to M6G Graviton. And that more than makes up the difference in less discount you get from a standard RI or a standard instance savings plan versus a compute plan. So it might seem like it's a little less discount up front, but when you look at the entire cost of ownership over the year with that modernization, it more than offsets that and actually puts you even more net positive.
So we had a question, but still on the savings plan and NRI section, and it's around the fact that the discount, you'll start to see a discount from the next month onward because you're paying less. But there was a question about if you're starting to see a discount immediately, why would the break-even point be 7 to 9 months?
Yeah, so I mean, break-even point, if it's a no upfront, you're going to have it pretty much be right away. I guess that, you know, some of this depends on if you're buying partial upfront or all upfronts and how your organization from an accounting perspective treats those. That's definitely some conversation in terms of accounting you want to have with your financial team and be dictated and dependent based on different tax needs and things that you have that we are out of control with. However, you know, when you look at what the total cost is of that, you take in the upfront piece, let's say a partial upfront where you're paying about 50% of that total cost for the year upfront, and the other 50% is essentially divided by 12 months, spread out over each month. What we found is that on a 1-year plan, you're going to be getting that ROI positive with the cash upfront included around month 7 usually. So to be clear, no upfront, you're going to see savings immediately. You gave us no cash, and within the very hour that you enable that, your bill will be dropped on those applied resources.
Awesome. Looking through all these last questions. We have some questions around, I don't know, so recommendations for, like, there's a lot of people are asking about other services that we didn't cover in this call. So we're in our final minutes here. So what would you recommend for people who have a service that we didn't cover here? What's the best way for them to find out more about how they can optimize those other things like CloudWatch or EMR, or evaluate whether, you know, one service or another is a better choice? And there's some questions around that as well. What kind of advice do you give for those outside of these 9 that we've already talked about on how to start thinking about finding optimization opportunities for those other areas?
Yeah, so one question that was asked in the chat is around, is Compute Optimizer serve RDS instances? And right now, presently, it does not. So what I recommend to that, since it's usually a big piece of your optimization play, making sure your databases are the right size and the right resource for the job, is you can still do the describe instances request command from your command line. And instead of saying like EC2 describe instances, you say RDS describe instances, and you can get that CloudWatch data that'll tell you what the provisioned CPU is versus what's utilized, the average queue depth and queue length on those database instances, as well as like the freeable addressable storage. And what I tend to do and recommend with most customers is start off with your RDS instances that never max out over 30% over like a 2-week to 1-month period. If you're starting with none, you know, the ones that never max at that 30% benchmark, that's a really good indicator of what's idle, what isn't being used, or what is over provisioned. Some of those might be read replicas, and so it might be expected that they don't have a lot of CPU going on, and it's kind of intermittent. However, those can still be sized as well accordingly. So don't let that throw you off if it's a replica. But really what I would look at is like, that's the low-hanging fruit, and Compute Optimizer is kind of going to be making that assumption as a first guess as well as we develop that product. Kind of the last part on databases, you'll find, especially with RDS, let's say you have instances where there's a lot of incoming connections and a lot of read-write activity, which is also available. That data is, you can see through CloudWatch. Those are the types of instances where maybe you would benefit from putting an Elasticache node in front of that database for commonly queried stuff that can just be served from that cache and take some of the CPU hit off of the actual instance on RDS itself. So once you put that cache node in front of it, you can then look at downsizing the RDS instance accordingly and save you a lot of money. So it's just some things to consider.
All right, we are just at time. Is there any last thoughts, Carlos, that you want to say before we end?
Yeah, well, this is a journey, right? I think people sometimes think that they have to do everything today, you know, and it's not only a journey about cost optimization, it's about cloud financial management in general, you know? And I think it's important for people to understand that they should be able to understand, first of all, the source of their cost, then you can optimize, then you should be able to do things like predict and forecast, and finally, how to do these things, let's say, within your organization. Who takes care of what does the tech people do? What does the finance people do? So all these things are practice. They're pretty much like training for a marathon, right? It's the same principle. And you want to think of this in terms of a staged approach, right? So don't despair. There's lots of help, and there's a lot of things that people have done already in the past that can help you to actually jumpstart into that journey.
Thank you so much, Carlos. Thank you so much, Biddle. I really appreciate you guys being here today. And thank you everybody in the audience. It's been great. Thank you all. Have a good day.
Thank you.